maximize its usage for your vehicle. Okay, if you take a look at this chart, you're going to see right here that we have this diagram here of the canister. This represents the canister right here. And Pavel, a minute ago, you were asking me where those different pieces went to. This right here would represent that elbow on the canister as it comes up out of the top. Now, obviously, when we hook that to the engine, and we'll get to that in just a second, there's going to be a vacuum draw on the system, and that draw will need to have, that's why we have the bubbler valve on there. And I don't have it pictured on here, but the air has to flow through and go out. So that's why that valve is there. Mm-hmm. So it allows the pressure to pull air through the system. And in a minute, we're going to be talking about how you hook up that vacuum line, where you look for on your car to find the vacuum line, and the pressure and the type of pressure gauge and things that you're going to need in order to be able to determine if you are using the correct vacuum line and you're getting good pressure that you need for the system to be effective. Okay, so if you look at we have the positive symbol and the negative symbol. And on the outside of the canister, which is made of stainless steel, the negative charge is the negative side of the system is the outside canister, the stainless steel, and the positive side is this rod that we call the anode. So the outside acts as the cathode, the inside acts as the anode. What happens is, as that charge, that electrical charge, goes positively from the rod it flows through to the outside surface of the canister through the liquid. It causes the water molecule, which is 2 atoms of hydrogen, 1 atom of oxygen, to split in half. And it stabilizes the molecule in that state. And that is called Brown's gas, or you'll hear us refer to it as hydroxy gas. With the air pressure flowing through the system, it is sucked out of this valve here, that elbow, that vacuum hole elbow that I mentioned there. And through a vacuum line, it goes into the intake manifold of your car. Now, we're going to be talking some more about where you put it in the intake manifold and some of the strategies of how to find a good vacuum line and what will constitute an effective line to have your system in. Then as the gas goes into the intake manifold, it goes through the intake valve and into the combustion chamber. And let me explain this as best I can. Right now, the way this chart is showing, you'll see that this little thing right here represents this is a fuel injector. And imagine, if you can, that the fuel is injected into the cylinder, and at the same time, air and the hydroxy gas is drawn in, and then these 2 valves will close up and seal the system, and the cylinder starts to create compression. The oxygen in the hydroxy gas attaches itself to the gasoline, the petroleum, and the hydrogen actually collects around the spark plug, because it's the lightest element. It's actually the lightest element in the universe, hydrogen is. And when that hydrogen explodes, it causes the fuel to burn more efficiently. Now, in a normal combustion engine, somewhere between 13 to 25% of the fuel that goes into the combustion chamber is released, is never even burned. It's pushed out in the form of harmful emissions. And it will come out of the exhaust during the exhaust cycle. It will come out and go into your exhaust pipes, into the catalytic converter. And in the catalytic converter, hopefully some more of it will be burned up. And then it goes out the muffler and it stinks up the air and pollutes our environment. With the hydrogen, however, in the system, it causes that fuel to burn more completely. And by doing that, the main byproduct of a well-tuned, properly operating hydrogen system is actually water vapor. As the hydrogen and oxygen go through the combustion cycle, they recombine into the water molecule, siphon a tremendous amount of heat off of the engine, and push it right out through the back of the car. Now, did that help you any? Commonly getting questions from people about these systems and what are the good systems out there to buy and who has good things. And we want to give you some good ideas about what you can expect from your vehicle and how to go about installing that in your car. So in a few minutes we're gonna move to some strategies that I think are going to be really helpful for you. But before we do that, I wanted to just bring up some cases of some people that we know about and some of the results that people are having. In fact, in my circle of influence, or the people that I've installed the product in, we have people having everywhere from no result at all to 40 to 50%. And one of the interesting things about that is, and people always ask me, is what do you got to do to get 40, 50%, and why do some people get no results at all?
Before you continue, can you explain what that 40 to 50% figure is? What is it you're referring to?
I'll give you an example on my car. I have a 1996 Camaro, and on my V6 Camaro, I routinely got between 13 and 15 miles to the gallon. So it was pretty bad. And I put the system in my car, and I went from averaging about 14 miles to the gallon to averaging around 20 to 21 miles to the gallon using the system. And so in my case, going from 14 miles to the gallon to 20, 21 miles to the gallon is about a 45 to 47% increase in mileage. So if you look at it in terms of your per gallon mileage, it would be how much more per gallon by percentage.
I see. That's what the figure is.
So another way you could look at it, and sometimes people will say, oh, Carl, I used to be able to get 220 miles to the gallon. Now it seems like I'm getting 280 miles out of a tank, per tank of gas. And so some people are more familiar with normally how many miles will they get on a tank, and that's kind of how they figure it out. But I kind of like to do the numbers all the way down to the per miles. And for example, one of the people that we installed the system in had a 2003 Dodge Durango. And he went from 10 miles to the gallon to 13 miles to the gallon. Well, 10 miles to the gallon to 13 miles to the gallon, that's a 30% increase. And 30%, that's significant. Mm-hmm. Mm-hmm. And we see that number commonly, somewhere between 20 and 40% increase on the cars that the system is installed properly. Now, as I was talking about before, I know that there are people that are not getting any results at all. And when we talk about the installation in a few minutes, I'm going to go over some of the reasons why people are having a hard time getting results. But the funny thing about it is we never know who it is that's going to get those results for sure. One of the dynamic variables, however, is definitely the condition of your vehicle. We recommend, if you're going to be getting any kind of hybrid hydroxy system, that you get a tune-up on your car and have some of the key sensors in the car checked to make sure that the car is functioning in its normal operating parameters. And the big sensor that gives us all the grief, fellas?
The O2 sensor.
That's right, the O2 sensor. And we'll be talking in greater detail about the O2 sensor. Walter has a tremendous amount of experience with O2 sensors, so we've beat our heads against the wall on those quite a few times. But we think we found some good strategies as to how we can work our way around them. The other sensor that a lot of people seem to have a problem with is the MAP sensor, or in some of the cars it's called the MAS sensor. And the MAP stands for maximum air pressure, and MAS is maximum air
manifold air